Okay, so YouTube wouldn't let me upload the whole video. It is a long video. So this paper is like the second half of the paper, and it's got the more kind of grade 8 and 9 kind of questions. So I'd recommend you do watch both, because there's a nice tricky bearings question in the first part of the paper, but this is definitely tailored towards the end kind of style questions on the exam. And also look through the predicted paper 1 and 2, and any other topics that didn't come up, use them as revision as well. Nice circle theorem. So I'm told that B, D, E and F are 4 points on a circle, and the ABC is a tangent to the circle. So automatically I should be either thinking tangent and a radius, which doesn't apply here because there is no radius, or tangent and a chord. What do I know about a tangent and a chord? That is where I have the alternate segment theorem, and that states that essentially if you have a tangent and it intersects a chord, then the angle formed, so this angle here between the tangent and the chord, so in this case this angle here, the angle formed between the tangent and the chord is going to be equal to the angle in the alternate segment. So if you look at the chord, this is the segment the first angle is in. So this whole thing is going to be the alternate segment. But some people find that confusing. So if you just think about it as this is the chord, okay, so this angle and this angle are touching the chord, so they cannot be the alternate segment, then the only angle that is left is this one over here. So that's the alternate segment theorem. So that should spring to mind. And then what else? Well, sneaky. This is sometimes sneaky because people just find it hard to visualize, but that's why it's good to have a highlighter and just literally go around and see what shapes you can make out. This is a cyclic quadrilateral. And you know that cyclic quadrilateral, in a cyclic quadrilateral, and that is when all of the vertices are touching the circumference of the circle, which this one is, opposite angles sum to 180. So these are the two circle theorems that are screaming out at me initially. So let's see if they apply. So angle DBE is 25 degrees, great. The sines of angle BDE, so this angle here, to BFE, this angle here. Okay, so what is good about this is that already I can see that these, if I think about it as a quadrilateral, so remember that you can think about the whole thing as a quadrilateral, I know that these two angles must sum to make 180. So let's try that again. So BDE is 3 parts. So let's just call that 3x to 2x, just so that I have something. It's in the ratio 3 to 2. So whatever the angle is, I can call that. I don't know why I'm struggling to explain why you turn it into 3x. So what a ratio 3 to 2 means is that for every 3 parts, or let's say degrees, for every 3 degrees that this angle has, the other angle has 2 degrees. So whatever the degrees is, 3 lots of x is this angle, and this angle is 2x. And the reason I do that is because I can then form an equation. So 3x plus 2x must equal 180. And the reason would be cyclic quadrilateral sums to 180. So 5x equals 180. So therefore x equals 180 divided by 5, which is 36 degrees. Therefore, 3 times 36 is 108. So this angle here, oh, why does it do that? So this angle here is 108 degrees, and then 2 times 36 is 72. So this angle here is 72 degrees. Okay. Now, there are, sorry, there are a few ways that we can go about the next part. So one of them is using the alternate segment theorem. So there's actually just so many ways that we can do this, but let's have a look at this. So this is a chord, and this little angle here must be equal to this little angle here, and I could go about that way if I wanted to. Yeah, why not? Let's go about that way. So if I just took this triangle out, I know that this is 25 degrees, this is 108 degrees, so I could work out what this is by just doing 180, take 108, take 25 equals 47. And I'd say, because as angles in triangles sum to 180, don't forget your reasons. It's really important you write your reasons, because without reasons you don't get the marks, even for the basic things. And obviously for the alternate segment theorem, you would have written, actually for the alternate segment theorem, you can just write alternate segment theorem, that's okay. So therefore, this little bit here is 47 degrees. And what are we trying to work out? ABD. Okay, so we've worked it out. So ABD is 47 degrees. Another way you could have done it is, you know that this is a chord as well. And all of this, so the angle between the tangent and the chord is equal to the angle in the alternate segment. So all of this must have equaled 72. So you know that this angle, 25 degrees, and this must sum to 72 degrees. So 72 take 25 is 47. That's another way you could have done it. There are loads of other ways that you could have done it, but essentially alternate segment theorem, cyclic quadrilateral is the key circle theorems that would have been used here, and hopefully they make sense. So here's another circle theorem. So ABCD are 4 points on the circle, BCE is a straight line, angle DAC is 25 degrees, and then we know that these two sides are the same as are these two. So I know that they're going to form isosceles triangles. Okay, so what can I do first? The ultimate aim is to work out what this angle here is. I can deal with that later. First, let's deal with what I know. So that's 25 degrees, which means that I can work out what these two angles here would be. So 180, take 25 is 155, divided by 2 is 77.5. And the reason I've done this is because AD equals AC, therefore triangle ADC is isosceles, and base angles of an isosceles triangle are equal. So it wants reasons, so that would be my reason. Next, I know that AB equals BC. AB equals BC. Therefore, triangle ABC is isosceles. So if I can work out any of the angles, then I know that I can do stuff with them. So let's try and think outside the box. So like I said, always have highlighters and highlight round just to see what shapes are present. You're always looking for either triangles, tangents, cyclic quadrilaterals, and in this case you have a nice cyclic quadrilateral here. Sometimes it's hard to spot, which is why I really push the highlighter technique. Just try and highlight as many different things as you can, otherwise you won't be able to do the question. So opposite angles, so we'll save this reason till later. So opposite angles in a cyclic quadrilateral sum to 180 degrees. Therefore, I can figure out what this angle here is. Therefore, angle ABC equals 180 take 77.5, which is 180 take away 77.5 equals 102.5 degrees. So this angle here is 102.5 degrees, and this is isosceles. Therefore, angle BAC equals angle BCA, as base angles are equal. And the working I do is 180 take away 102.5 divided by 2, because there's 2 of them. So 180 take away 102.5 leaves me with 155 over 2, which is 77.5. So 77.5 divided by 2 leaves me with 38.75. So these two angles are 38.75. Okay, so now I have essentially all the angles I need, because the last part is that this BCE equals straight line. So all angles sum to 180. Therefore, angle DCE must equal 180 take away 77.5 take away 38.75, which equals 180 take away answer take away 77.5 is 63.75. And those are all the reasons that you should give. So recognizing that it's an isosceles triangle, saying what that means. The cool thing about an isosceles triangle is it's got 2 equal sides and 2 equal base angles. Then spotting the cyclic quadrilateral, and then the last bit is just a straight line. So these are pretty simple steps. That the issue with circle theorems is spotting it. So highlight everything that you can to try and just pick out shapes and things, and always just start by working out the things that you know. And yep. Okay, so algebraic proof is really actually quite simple if you just know these few things. So in order to so imagine you have any number. Let's generally call any number n. N could be 2, it could be 77, it could be 89, it could be anything. So n could be odd or even. I don't know whether it's even or odd because I don't know what it is, but I know that if I multiply anything by 2, it becomes even. Let's just try that. 2 times 2, that becomes 4. 77 times 2, that becomes 154. 89 times 2, that would become 178. All of these are even numbers. So in order to prove something is even, you just show that it's a multiple of 2. So you can times it by 2. So generally what we do is we say that any even number is represented by 2n. Okay, because if whether it's odd or whether it's even, if we times it by 2, it will still be even. So in order to represent an even number algebraically, we call it 2n. Therefore, in order to represent an odd number, if an even number is 2n, an odd number is always 1 more or 1 less than an even number. So 2n could be 2n, an odd number could be 2n plus 1, or you could represent it as 2n minus 1. And that's like the really basic key thing that you just need to know and understand. Then the other thing is knowing what consecutive means. So consecutive numbers are literally numbers that are after each other on the timeline. I mean number line. However, so a consecutive number, any number could be n. I haven't been told whether it's odd or even. I'm just stating any number. So any number could be n. Its next number, its consecutive number would be n plus 1. The number after that would be n plus 2, and then n plus 3, and so forth. And that is how you do consecutive numbers if they are just any old bog standard number. Because if n was, let's say, 4, n plus 1 would be 4 plus 1, which is 5. n plus 2 would be 4 plus 2, which is 6. So that's how we get that. Now, the difficulty sometimes comes when it's saying consecutive odd numbers or consecutive even numbers. So if we look at our odd numbers, and let's say we started with 2n, because you're always going to, in order to prove something is odd or even, it needs to be 2n, because that's the only way you can prove that it's even, and subtracting from an even number is the only way you can prove that it's odd. So we're always going to be dealing with 2n, or 2n plus 1 is our first thing. So the sum of the squares of two consecutive odd numbers. So I'm going to use 2n plus 1 as my first odd number. Now, the common mistake would be to say, oh, okay, well, the next one is going to be 2n plus 2. But no, because that would then be the next even number. Like, imagine n is 7, okay? So if n is 7, 2n plus 1 is 14 plus 1, which is 15. But 14 plus 2 is 16, okay? So that is why you always have to skip 1. So it would be 2n plus 3 would be the next consecutive number. If in doubt, literally just pick a number and substitute it in and see if that works for consecutive odd numbers. And then you'll be like, oh yeah, okay? So this is where a little bit of difficulty arises in this question, but hopefully that made it a little bit clearer. So I need to prove algebraically that the sum, which means add, of the squares, so whatever it is, I'm going to square it, of the two consecutive odd numbers is always even. So my first odd number is 2n plus 1, and for it to be consecutive, it would need to be 2n plus 3. So what am I doing with these two expressions? That's my first odd number, that's my next odd number. I need to know that the sum of the squares of these, so I'm going to have to square these expressions and add them together. So let's have a go at doing that. That would be 2n plus 1, 2n plus 1, plus 2n plus 3, 2n plus 3. This is just an expanding brackets exercise, so I'm just going to do this quickly. So 4n squared, actually I'll just do the whole thing, plus 2n plus 2n plus 1, and then plus 4n squared plus 6n plus 6n plus 9. Some of you might have noticed that when you're expanding brackets like these, the middle two terms always combine, so you can just skip that step, but it's better be safe than sorry, to be fair. So I'm just simplifying this now. So 4n squared plus 12n plus 9. So these are the squares, okay, of two consecutive numbers. The sum of them I need to prove is always even. So let's simplify this expression. So that would be 8n squared. 4n plus 12n is 16n, and 1 plus 9 is 10. Now, to prove that something is even, you just have to factorize it and show that it's a multiple of 2. So I'm just going to factorize that and take 2 out of it. So that would that could be expressed as 2 lots of 4n squared plus 8n plus 5. And then I just have to show, and I just have to like do a little sentence explaining what I mean. So anything, or let's go fancy. You could say 2n plus 1 squared plus 2n plus 3 squared can be written as 2 4n squared plus 8n plus 5, and anything that is multiplied by 2 is even. Therefore, I have proved it algebraically. Okay, so this is a little bit of a nasty, well, not nasty, just challenging question. Well, just not even it's just a long question that just requires you to go through the process. So the key thing that we need to remember is that in order to add or subtract fractions, they just need the same denominator. Okay, so that's the key thing that you just need for basic fractions, algebraic fractions, any kind of fractions. So What we want to do is probably just start with this bit and ignore the -3 till later. Just separate it and work on bit by bit and simplify it and then bring everything together. So in order to add these two together, I'm going to need to write them as fractions that have the same denominator. And in this case, because they're algebraic fractions, I'm just going to not worry about finding the lowest common multiple. I'm just going to write it as x minus 4, x plus 4. So what I do essentially is, let's say you had a over b plus c over d. The lowest, sorry, your common denominator would have to be bringing both these denominators together. So your common denominator would be bd. And then what have you multiplied this fraction by to get to bd? You've multiplied by d, so that would become ad plus cb, because what have you multiplied this by? You've multiplied it by b. So essentially we do exactly the same with algebra. So let's say it was a over x minus 4 plus b over x plus 4. What am I doing? My common denominator is going to have to be the two denominators multiplied together. And then you just think to yourself, what have I multiplied this by to get to this denominator? Well, I've multiplied by x plus 4, so I need to do the same to the numerator. And similarly here, what have I multiplied this denominator by? I've multiplied by this, so that would need to be like that. So hopefully that simplifies it a little bit, but that's why this becomes the denominator. So using that method, what have I multiplied this fraction by to get to this denominator? I've multiplied by x plus 4. So whenever you are changing a fraction, in order to keep it in the same proportion, you need to multiply whatever you've multiplied the denominator by, you need to multiply the numerator by the same thing, otherwise you change the value of the fraction. So that's why I'm doing this. So that would become x minus 3, x plus 4 plus, and then this fraction here I have multiplied by x minus 4, so that would be 2x plus 2, x minus 4. Now let's just clear this up and make it a little bit neater. So I write all of this under one fraction, x minus 4, x plus 4, and then this x minus 3, x plus 4, plus 2x plus 2, x minus 4 is the next part of just like simplifying that. So generally with algebraic fractions, you're going to have to do some manipulation. You're generally going to have to expand the brackets, factorize them, just keep expanding and factorizing until something clicks. So over here, I know that my ultimate aim is to get the denominator in this form. And that's pretty simple because I can tell that this is going to be the difference of the two squares. So if I actually expanded that, x minus 4, x plus 4, x times x is x squared, 4 times x is 4x, minus 4x, and then minus 16, that cancels. So already I'm left with that. So you could start by just simplifying your denominator and show you're working like I have a small space to work in, but you have good working on your big page. So that's step 1 for the denominator. Working out 2, I'm going to expand this bracket. So x minus 3, x plus 4 is x squared plus 4x minus 3x minus 12. So that would simplify to x squared plus x minus 12. And then I'm adding, this is where it's annoying running out of space. I'm adding, so that's my working for 1 and 2. Now let's do the working out for the third part. So this part here. So 2x plus 2, x minus 4, expand it, that would be 2x squared minus 8x plus 2x minus 8. Simplify, so minus 8 plus 2 is minus 6. So then you've got this, 2x squared minus 6x minus 8. Now we can see if we can simplify it. So x squared plus 2x squared would give me 3x squared. x minus 6x is going to be minus 5x. And then minus 12 minus 8 is minus 20. So I'd be left with this, which I could factorise if I wanted to. There's a few, I mean, there are actually so many ways that you can do this. So the key is just expanding and factorising and manipulating it until you can simplify it. But the point is that I have now simplified this to this. I could then factorise the numerator, but I'm not going to, not just yet. Because what I then need to do is subtract 3. So to turn any number into a fraction, you just write it as over 1. So that would become 3 over 1. But in order to add or subtract fractions, they need to have the same denominator. So because this is 1, and when I multiply anything by 1, it stays the same, this fraction is going to stay the same, because all I need to do is multiply this fraction by x squared minus 16 so that they have the same denominator. So this would become 3 brackets x squared minus 16 over x squared minus 16. Now, what I can do is expand this. So that would become 3x squared minus 5x minus 20 minus, and then 3 times x squared is minus 3x squared, and then minus 3 times by minus 16 is going to be plus 48. Let's just double check, because honestly, sometimes it's the simple things that lead to the whole question going wrong. So thankfully that's right. And that is all going to be over x squared minus 16. So let's clear this up and continue simplifying. So 3x squared minus 3x squared cancels. Then you're left with minus 5x, and then minus 20 plus 48. So 48 take 20 is 28. Have I missed something? Maybe not. No, I'm sure it's fine. So it's not always, sometimes people get really confused by this because they're like, it's not a positive. It doesn't matter. All it means is a and b are integers, which they are. So you could leave it as minus 5x plus 28 is over x squared minus 16. Or you could say 28 minus 5x over x squared minus 16, because it's just nicer not having a, what's it called, negative as the beginning. And you need to find the value of a and the value of b. So the value of a is minus 5 and the value of b is 28. There is a possibility I may have slipped up somewhere, but I'm trying to get this done so it can be released in time. So if I have, call me out on it and I'll correct it in a comment. Okay, so the next up is another slightly tricky algebraic fraction one. This time it's division. So with adding and subtracting, you need the same denominator. With division and multiplying, you don't need to bother. You don't need to worry about denominators, okay? All you need to know is for multiplication, you just multiply the numerators together and you multiply the denominators together. And then for division, you remember keep, change, flip, and that's it. So show that this can be written in that form. So all we're going to do is keep the first fraction as it is, change the second fraction. So 8x cubed, or this should be pink because it's a pink thing. So 8x cubed divided by 4x squared minus 36 times by 2x minus 3 over 4x to the power of 4. Now, you might not, but hopefully you're getting good at spotting the difference of two squares. So the difference of two squares is literally where you have a square number, x squared, minus another square number. And the way the difference of two squares factorizes, it's always going to be x plus the square root of 16, x minus the square root of 16. So essentially x plus 4, x minus 4, like the square root of whatever your number is. So in this case, I know that this is going to factorize to 2x plus 6 and 2x minus 6, because 4 is a square number, so the square root of 4 is 2, and 6 is a square number, and the square root of 36 is 6. And the reason this always works is because when you expand it, because you've got one positive and one negative term, the middle two terms, they always cancel out. So let me just show you, if you don't believe me, that would become 4x squared minus 12x plus 12x minus 36. So this and this cancels out, and that is why you're left with 4x squared minus 36. So it's really important that you always look out for things like that, because in this case, I'm pretty sure it's going to matter. So I'm just going to rewrite that to make my life easier. So 2x plus 6 and then 2x minus 6 times by, and already I can see that that's making a difference. So if I expand this, that would be 2x minus 6 over 4x to the power 4. Now remember, when you're multiplying, you just multiply the numerators together and the denominators together. So that would be 8x cubed times by 2x minus 6 over 2x plus 6, 2x minus 6. You could write it like that if you wanted to. I'm just writing it like this just to show you, so that it might make it a little bit easier. So then remember, with a fraction, if you had, like, let's say 5 times 4 divided by 5, well, 5 divided by 5 is 1. So anything, so that would just end up being 4 over 1. So whenever you have anything on the top of the fraction that is the same as the bottom of the fraction, oops, was that minus? Yeah. They cancel out so long as the numerator and the denominator are products, which means every term is being multiplied. And it can be like things inside a bracket can count as one term, sort of. So I've then simplified this, and let's rewrite it over here. So once I've cancelled that out, I end up with 8x cubed as my numerator, and then 4x to the power 4 times by 2x plus 6. Now, there is a little bit of a hint over here. I know that I'm going to eventually divide, I want my numerator to be essentially divided by 8x cubed. So what that means, because I want it to be 1, the only way to get 1 is to divide 8x cubed by 8x cubed. So what that means is that I could take out a multiple of 2 from the bracket. So that could become 8x cubed divided by 4x to the power 4 times by, if I take out 2 out of the bracket, I'd be left with x plus 3. And 4x to the power 4 times by 2 is conveniently 8x to the power of 4. So I'd be left with 8x to the power 4 times by x plus 3. Now, if you're not confident with indices and you look at that and you're like, oh, I'm just brain fried, literally just take it back to its basics. So what does 8x cubed mean? It means 8 times x times x times x, and then 8 times x times x times x times x times by x plus 3. That's in a bracket. So what can cancel out? Well, 8 divided by 8 is 1, x divided by x, x divided by x, x divided by x. So the whole of the top cancels out to just 1. And on the denominator, you are left with x plus 3 and 1x on the outside. And there we have it. They haven't asked you what a is, but if they did, you would say that a is 3. So hopefully that helped a little bit. And the key is just keep going with the question and see where it takes you. Okay, so here you have been given a question that requires you to use the area of a triangle. Now, the area of a triangle is half AB sine C. It is given to you on the formula sheet, but you need to know how to use it. So I'm told that the area of triangle ABC is 4 root 3. meters squared, and I need to find the value of x, which is located here. So let's think about what I can do. First things first, with advanced trigonometry, you want to label your triangle, and remember you can ignore the labels they have given you. So remember, the big letter relates to an angle, and the little letters, so A and B, relate to sides. So I want C to be over here. That means this is going to be little c. It then doesn't matter which is A and B, so I'll just call this one A. So it's going to be big A, and this is B, and this will be little b. So now I've labelled it, I can substitute into my formula. I know that the area is 4 root 3, so I'm going to say 4 root 3 must equal a half times by A, which is this, x plus 2, times by B, which is this, 2x minus 3, times by sine C. And sine C, well, C, angle C, is 60 degrees. So what can I do? Well, I can simplify first. So I know that, let's rearrange it so it's all of the things that I can divide by. X plus 2 brackets 2x minus 3. So this is the algebra over here, and this is the numbers. So what I can do is just divide both sides by a half times by sine 60. You can do it but step by step. So I could have done 4 root 3 divided by half and then divided by sine 60, or you could do it actually fine. Let's do it in step by step just so that I don't confuse anyone. So I'm timesing by a half. So step 1, I want to divide both sides by a half. So dividing by a half is the same as timesing by 2, but if you're not sure, still just enter it into your calculator, and you'd see that that becomes 8 root 3. So 8 root 3 equals sine 60 times by this. And then I'm just going to have to divide 8 root 3 by sine 60, which is 16. So essentially what you've done is, first of all, you have just substituted into the formula, and then what you're doing is you're trying to look for all of the values that are numerical and just move them to the other side of the equation. So you're just left with the algebra on one side and numbers on the other. So let's expand the brackets. So x times 2x would be 2x squared. X times minus 3 is minus 3x. 2 times 2x is 4x. And 2 times minus 3 is minus 6. So I know that 16 is 2x squared. Minus 3 plus 4 is 1 minus 6. Okay, so now I have a quadratic. And what do you do in order to solve a quadratic? In order to solve a quadratic, you need to get it, rearrange it so it's equal to 0. So we're going to subtract 16 from both sides. So I'd be left with 2x squared plus x, and then minus 6 minus 16 leaves me with minus 22 equals 0. And you could use the quadratic formula. So I'm just going to go ahead and use the quadratic formula. So with every quadratic, you know that it can be expressed in the form ax squared plus bx plus c. So therefore, with this equation, I know the value of a is 2, the value of b is 1, and the value of c is minus 22. So I'm just going to substitute that into the quadratic formula. So x is going to be minus 1 plus or minus the square root of 1 squared minus 4 times 2 times minus 22 over, and then 2 times a is 4. So I can simplify that. It would be 1 take away, and then 4 times 2 times negative 22 is 176. So that would be the next step, and then the final step is minus 1 plus or minus the square root of 177 over 4. So therefore my final answers are going to be x is minus 1 plus root 177 over 4, or x is minus 1 minus 177 over 4. So these would be my two solutions. and let's see what they bring. So -1 plus 177 over 4 gives me 3.076033. And then if I just use the little arrows, oh, I deleted it, but you can just use the little arrows to change it, so you don't have to type the whole thing out again. But obviously don't worry if you do, because I just had to, because it deleted itself. So, or x is minus 3.57603. Now, because I'm dealing with a length, I know that it can't be negative, because you can't have a negative length. A length is like a thing that exists in the 3D world. It can't be negative. Like, you can go underwater with a length, but the length is still positive. So whenever you have any kind of length, this cannot be a possible solution. This is your only solution. And it says give your answer correct to 3 significant figures. So x is 3.08. And that's that question. Okay, so here I've got 2 triangles, non-right angled triangles. So even if the little helpful thing at the top in the right hand corner didn't tell me what I was going to be doing, you should think to yourself in an exam, 2 triangles, none of them are right angled, so I'm going to be using sine and cosine or area of a triangle. So let's have a look. I have triangle ABD and DBC, and I need to work out the length of AD. And then I need to give my answer to 3 significant figures. Okay, so the triangle that I have the most information for is this one here, and that makes sense because in the exam they're not going to just give you everything and give you a useless triangle. So let's start with this one here. So I've got 105 degrees, I've got an angle, another angle, a side, and what would be useful for me, considering I'm going to be working on this triangle, is to figure out what this side here is. So I've got a side and its corresponding angle, and an angle and its corresponding side. So a good thing to use here would be the sine rule. So I'm trying to work out a side, and remember, whatever you're trying to work out, you want to be the numerator. So I'm going to say A over sine A equals B over sine B, and just substitute those values in. So this could be A, and this would be big A, this would be little b, sorry, big B, this would be little b. Remember, the side, the angle is the big letter, the little letter is the side, and they're always opposite each other. They're corresponding to each other. So A over sine 28 must equal B, 13.2 over sine 105. Therefore, A must equal 13.2 over sine 105 times by sine 28. So a nice and easy one, really, to begin with. So I'm just rearranging it to make A the subject. This is why rearranging formula is so important. So 13.2 over sine 105 times by sine 28. Didn't close the bracket. Let's just check. Yeah. So A is 6.415631. So this length here is 6.41. I'm just going to write it out here on the top just to save for later in case I need it. That's just what I always do, because it's an exam. I want to be careful. So 6.415631 988. Okay, now I have a side. I have a side here. Can I work out anything else? No. And yeah, okay, so this is one angle. I only have one angle. Generally, if you only have one angle and you have 2 sides and you're trying to work out a third side, you're going to be using the cosine rule. So the cosine rule is a squared equals b squared plus c squared, take away 2bc cos a. So once again, you label your triangle according to what you want. So the only angle you've been given is this one. So I'm going to label that A. and the side I'm trying to find is the little a. That's the cool thing about the cosine rule. If you have the angle opposite to the side that you're trying to find, and you have the lengths of two other sides, then the cosine rule is a dream. So a squared is going to, and this, it doesn't matter which one's b, which one's c. So a squared equals, is it still memorized? Yep. 6.41 squared plus 8.9 squared. Oh, I put them the wrong way around, but it doesn't matter. Times by 2 times 6.4 times 8.9 times by cos 83. So a squared is equal to, so I've got my answer, squared plus 8.9 squared equals 120.3703338. I always tend to just do it in 2 parts just because it minimizes the risk of a miscalculation, a typing error, exam madness. It just happens. So 2 times by 6.415631988 times by 8.9 times by cos 83 is 13.91726567. A squared is therefore going to be 120.37. Take 13.917, and that gives me 106.4530681. To work out a, I'm going to do the square root of this. So a is the square root of answer, which is 10.317. And that is what I'm trying to find out. I'm trying to find out the length of DA, and that is a. So a equals 10.3 to 3 significant figures. Okay, so 3D trigonometry is just about trying to visualize triangles everywhere, essentially. So A, B, C, D, E, F, G, H is a cuboid, and FE has a length of 8 centimeters, and it's a cuboid. That means that this length here is going to be 8, this length here is going to be 8, as is this length here, so that's pretty cool. AE, so this diagonal here has a length of 12 centimeters. So already we should be able to see that there's a triangle that's formed there. That would be 12 centimeters, that's 8 centimeters. And I could use Pythagoras to work out what this length here is, if I should need to. I'm guessing I most likely will. So I'm just going to work it out. So 12 squared, take 8 squared equals, and then the square root of 80 is 8.9. So AF and any of these vertical heights is going to be 8.9442791. So I know that. What else do I know? I know that angle GFE, so GFE is going to be here. So GFE is this angle here. Okay, and I need to find the size of angle EDG. So EDG, okay, right. So I wrote the wrong angle. It's angle FEG, because that wouldn't make sense, because this would be a right angle. So if I just drew this as a plan, this is what it would look like. Basically the intersections of two, with these it's like sometimes really difficult to visualize, but imagine a literal box, like I don't know why I have a breadstick box here, but imagine anything that you've had in a cardboard box, and imagine laying it flat, and you can see that there'd be right angles at every corner. So that's how we know that we use trigonometry. So this would be a right angle, and this angle here is 39 degrees. And then we know that this length here is 8. We haven't been told this length here, but this length here is going to be useful because I need to find the size of angle EDG, which is going to be this angle here. So it's going to be a right angled triangle that is formed using the hypotenuse of this triangle here. So it's about kind of seeing where they all interlink, but it is hard. It's especially if you're not a visual person. I get that it is tricky to try and visualize it. So hopefully you can see that if you laid it flat, it would be a right angle triangle. Okay, so what have we got? We've got our basic trigonometry. So I used Pythagoras. I am rushing a little bit because I created a mammoth of a thing. I don't know why I did that, and time is ticking. So what are we doing? We're doing SOHCAHTOA. So what am I trying to find? The hypotenuse. That's the hypotenuse. I've been given the adjacent. Which one uses A and H? That's K. So I know that cos 39 equals adjacent 8 over hypotenuse. So therefore, the hypotenuse is going to be 8 over cos 39. So 8 divided by cos 39 equals 10.294. So I know that, what was that letter here? GE. Okay, so I know that GE is 10.29407,653. And the next part is using this triangle here to work out this angle here. So if that's D, that's E, and that's G. DE, I've already worked out that length is 8.9. And the hypotenuse, I've just worked out that length is 10.29. So therefore, I can once again use Pythagoras. So I've got SOHCAHTOA. What have I been given? So this is my given angle. This is the hypotenuse. This is the adjacent, and this is the opposite. So therefore, I'm using O and A. So tan theta is opposite over adjacent. So tan theta, and theta just represents the angle. Opposite is 10.29 over 8.94. So answer divided by 8.94 to 7191 equals, so tan theta is 1.1509. So therefore theta is going to be shift tan answer, which is 49.01340202. So just give your answer to the nearest degree. So EDG, angle EDG equals 49 degrees. And that's how we do 3D trigonometry. Even if you just manage to do the first bit of the Pythagoras, of the finding the sides, of doing a little bit, every tiny little bit counts. It doesn't matter. Honestly, just picking up marks wherever you can, like a little vacuum, just scooping up everything is the best way to get the best grade. Like, you can get a grade 9 by making the silliest mistakes and not even doing the last two. Like, you know, just marks are great. So just never give up on a question and always try and just scoop up something. Okay, so sometimes iteration shows up like this, where you're being asked to show that and use the formula to find an estimate for the solution. So I just thought I'd go through this type of question as well. So here you're being told to show that the equation x cubed plus x equals 6 has a solution between x equals 1 and x equals 2. So the first thing you want to do when you've got a question like this is to rearrange it to make it equal to 0. So x cubed plus x minus 6 equals 0. And then what we want to do is substitute the values that they've given us. So, I mean, most of the time it's already going to be equal to 0, but just in case it isn't, I put one like this. So first of all, we substitute the values. So we'd say 1 cubed plus 1 minus 6 equals, so 1 cubed, 1 plus 1 is 2, 2 minus 6 is minus 4. So when I substitute 1, I end up with minus 4. Then I try and do the same with x is 2. So 2 cubed plus 2 minus 6 equals 8 plus 2, which is 10, minus 6, which is 10 minus 6 is positive 4. So when I substitute 2 in, I end up with 4. And what that essentially means is wherever your cube graph is, the solution is going to be between negative 4 and 4. So when x, sorry, I'm very tired. Essentially, you are saying that if there's a change in sign, so if it goes from a negative to a positive, it means that it must have crossed the x-axis. So that is all you are saying. So when you are trying to show that an equation has a solution between two values, you substitute those two values into the equation, and one of them is going to be a negative, one of them is going to be a positive, and you say there is a change in sign, therefore the solution lies between 1 and 2. So because there's a change in sign, that means that the graph must cross in between those values. Sorry, I really need a coffee or something. Okay, right. For the next question, show that the equation can be rearranged to give this. All you're doing is you're trying to rearrange this equation in the form that they want. So x cubed, you can see that you have 6 here and that you're subtracting x. So the first thing you want to do is just take x from both sides. So x cubed is going to be equal to 6 minus x. And then the next step is you cube root both sides. So x equals the cubed root of 6 minus x. Very simple generally, but it's just not always, so it's not generally going to be the instinctive way you're going to want to rearrange. It's rearranging in a way that they have instructed you to. So just be mindful of that. Look at what they want you to rearrange and then use that to give you clues. And then starting with x equals 2, use the iteration formula. So remember, with iteration, all this means, don't be afraid of the fact that it's got like so it's like a bottom indice or whatever. All it means, oh, and that should say xn over there. So all it means is, imagine that just means the next term, and that is the original term. So xn is the original term, xn plus 1 is literally the term after that. So if x0 equals 2, well, x0 is the original term. So to work out x1, I'm going to need to do the cubed root of 6 minus, like if I'm using the formula, xn. But in this case, it's going to be 2 because I used the previous term. So like to work out the next term, which is x1, n plus 1, I've used this. Then to work out x2, I'm going to do the same, except whatever this answer is, which I need to type into a calculator, that's going to be my answer there. Now, really quickly, I have gone through this before, but just in case, whenever you're using iteration, and I'm explaining this very poorly, but I'm really not feeling well, so I'm trying to power on through. Okay, step 1 is, you know that the first term is 2. So you press 2 equals, okay, into a calculator. You press 2 equals. If it said x0 is 17, you press 17 equals. Then what you do is you type in the formula. So in this case, you're going to type in the cubed root of 6 minus 2, okay, like that. And then you're going to press equals again. And that's going to tell you the first term. So that is 1.587401052. And now what you do is you use the little arrows and you go and you press delete where the 2 is, and instead you press answer. And then it automatically calculates it for you. So 1.6402050079, and then x3 is going to be the same. Take away answer. So technically this is that, and this answer is that. Calculator has stored that for you. You just press, and it gives you 1.63363622. You keep on pressing equals, and it gives you the next one. So x4 would be 1.6344, x5 would be 1.63435. Now, it says to find an estimate for the solution. Sometimes it's going to tell you try this iteration 3 times or 4 times. If it doesn't, then what you're looking for is the place where they all round to. So with the 4th and the 5th term, actually even this would round to 1.634. So 1.634, that would round to 1.634. So essentially, when you've got 2 or 3 terms that round to the same thing, you know you've done. But if you kept on pressing equals, you see, like, literally you get closer and closer and closer and closer to the value. So that is what we do if they haven't told us how many times to use the iteration formula. We'll just keep on doing it until we see a similar, like at least 2 of the decimal points would round to the same point. So really, actually very poorly explained iteration. I've done lots of videos, go through the past papers on iteration, even just go on paper 2. I'm just